Hello guys and welcome to the video. Today we're going to talk about a very important subject in data science, which is data wrangling. Now, you can't be a data scientist if you don't know how to process and clean the data that you get, because most of the time you're not going to get the data that is clean and perfect to start working with. Almost like 99% of the time, or even more than that, you will get the data that needs processing and needs cleaning and needs preparing for your model. And in order for you to do that, you need to have the set of skills that will allow you to quickly process the data and being able to change it in a certain way to fit your model. So what we're going to do today, we're going to go through most of the wrangling techniques, and hopefully it's going to be interesting for you, because as we said, it is a very, very important subject. Now, I have prepared the Python code here for the sake of saving time, because I received some complaints about the last video being very long. So in order for us to deal with that, we're gonna have this code here and we're gonna go through the code. Okay, I'm gonna walk you through the code here so that we can know exactly what each cell does in terms of data wrangling. So the first cell here includes the import, where we import our the libraries that we're gonna work with, and the first one is the pandas, which is a well-known, very strong library that will allow us to manipulate the data. The next library is the Matplotlib, which allows us to visualize the data, and the third one is the NumPy. NumPy is a very well-known and very famous library that will allow us to manipulate numbers and arrays. So on and so forth. The next cell we are going to call the next cell actually contains the path of the file that we're going to be working with. Now this file contains data from automotive manufacturers, and it describes the many features for cars, and we're going to go through those and we're going to see them. Now, the first thing we're going to do is we're going to run this cell here, and we're going to run this one here. So it's only saving the path in a variable here, the file name. Next, we're going to see how the data looks like without the next step, which is to define the headers. Because in many cases, you're going to receive data that doesn't have proper headers describing each column. So let's see here. All right, so as you can see here, the columns do not have meaningful names. So we're going to deal with that. We can simply just create a list here with all the column names. All right, so as you can see, there's the assembling, the normalized losses, the make, the fuel type, the aspiration, the number of doors, many features for each car. So we're going to run this one here. Simply, we are creating a list of column names, and in the next cell, we are assigning, we're actually reading the data, right? And we're assigning the headers for each column. We're assigning header names or column names for columns, and we're saving that in a data frame, okay? So that we can manipulate data frame. You can think of data frame as a table. So this is the first thing. Now, in this cell here, we're just gonna view the data. So if we say data frame.head, by default it brings the top 5, I guess. So top 5 rows. So as you can see here, the data looks much better than the one we saw here. So there's no column names here to start with, and here it looks clean and tidy somewhat. So as you can see here, there are some rows that has data that's incorrect, and this is a very common case that you're gonna face when you're receiving data. Like for example, some rows have question mark values, and maybe nan values, or not meaningful values that you might want to remove or replace. So in the next cell here, we're gonna replace the question mark with a nan. Nan is like a null in a SQL table or in a data table. So as you can see here, it's a data frame dot replace, and then we just mention the value that we want to be replaced, and we're gonna replace it with numpy or np dot nan. Okay, and then this is very important here to mention that in place equals true, because if we don't mention that, then it's not gonna replace the actual data in the data frame, right? It's just gonna be replaced in a different data frame in the memory. So if we wanna replace it in the actual data that we have, then we have to mention that in place equals true. After that, we're just gonna retrieve the head. Now, as you can see here, we're not having, we don't have the question mark anymore, and instead of that, we have the nan. Now, let's see, in the next cell, we're gonna see the nan values, or the missing values that we have. So we're gonna store all the missing values, which is data frame.isNull. So it's gonna check the value. If it's null or nan, then it's gonna return it, otherwise it's not. Now, you can see here that wherever the nan or the null value exists, you're gonna find true here, right? So this is just a quick way to show you if whether you have null values or not. Now, in the next cell, we're gonna count the values for each column. So for example, we have the normalized losses here. So what this cell does is that it takes each value in each column, and then it will give you the count of that value. So for example, if you want to know how many cars that has 2 doors, then it's simply gonna give you the 2 here, and then it's gonna show you how many rows having the value 2. Okay, so this is it here. We're just looping for over each column, and for each column we have the column dot value counts. So the value counts displays the count for each value in that column. So let's run it here. As you can see, it's very long actually. So for example, in the peak RPM, there are 37 cars with peak RPM 5500 and 36 cars for 4800. Okay. All right, so it's very long here. There are 202 front engine cars and 3 rear engine cars. Right, so that's one. Now here, what we're doing actually here is we're simply converting every value to checking each value for null. All right, and then we're counting wherever the value is true or wherever the value is false. So let's go back here. What we have done here is that we turned the data frame into this one here for trues and falses, and then we're counting them, simply counting them. This way you will be able to see how many null values you have in each of your columns here. So as you can see, width, there are 205 values that are not null. Height, 205 values that are not null. For example, here in the bore, we have 201 values that are not null, and we have 4 nulls in that column. This is very, very important, very beneficial. And the next, so the next here is if we want to know the mean for one column, that has numerical values, then we can show that, or we can know the mean using this code here. So we say the data frame for specific column. So we mentioned the column name here as type float dot mean. All right. So in this case, it's going to print the mean for that column. So the average of normalized losses is 122. All right. Now, next is a very important technique. So usually if you have null values, you might want to replace them with the average value in that column. So to do that, you just say here the column df and then the column name dot replace the numpy.nan with the average loss that we have found here. All right, and in place equals true, and this way we replace the null values with the average value. Okay, so we're doing the same thing here for the bore, because if you recall, we found some null values in the bore, and we're doing that here. We're doing the same for the horsepower. So it's a common practice that to replace the null values with the average. Okay, so let's check the value counts for the number of doors. So this will show us that we have 114 cars with 4 doors and then 89 with 2 doors. So again, so it's the column name dot value underscore counts. Now, so this statement or this code here shows us what is the maximum value that is being used, or that is being found in that column. So in the column number of doors, according to the value counts, we have the 4 door as the dominant value in that column. So it's the ID X max. So we're doing the same for the number of doors. So we're replacing the null values with 4 because it's the most common value in that column. Okay. Now we're gonna also see here that this is a very important piece of code here, because it drops all the rows where there's null value in the price column. So wherever there's a null in the price column, it drops the whole row. Okay, because this makes sense, because the price is our target column. This is the column that we're trying to predict. So it doesn't make any sense to have nulls in this specific column. So what we're doing is that we're using the drop an A, and then it takes the column that we want to drop any value, to drop any row where there's a null in this column, and yeah, and in place equals true. In place equals true, so that it will commit this change. All right, let's see. Okay, so now it has dropped all rows where there are null values in the price. Now, next we're gonna see the data types. So you can see here that it shows all the columns with their respective data type, and you can cast, or you can change the type of the column by using this this code here. So bore and stroke equals bore and stroke as type float. Normalized losses equals normalized losses as integer. So we're casting or changing the type of that column to integer, right? Yeah, so as you can see here, normalized losses is object, so we want to change that to integer. All right. Now, if we take a look again, yeah, so you can see it's now integer. Okay, and now we're going to cover the conversion. So if we want to convert a specific column's value, we see here we have the I think the MPG. Yeah, we have the MPG here, and it says liter per. We want to convert the MPG, the mile per gallon, to liters per kilometer per 100 kilometer. So we do that by just simply creating this, adding this column, the new column to df, to data frame, and then its value is going to be the city MPG divided by 300 by 235. Okay, so now we got a new column here. It's called city liter per 100 kilometers. Now the length, in this cell now, we're going to normalize the data in those two columns, the length and width. And this is very, very important because in many cases you might have astronomical values that doesn't need to be there, that doesn't need to be astronomical. At the end of the day, if you want to load it into your model does not care if it's a huge data, a huge value or not, as long as you normalize. So when you normalize, we usually do the following. We divide each value in the column by the maximum value in that column. So we normalize it. We reduce the value while keeping the same properties. All right. Now, next is a also very interesting and very important concept, which is the binning. Now, in the binning, you are turning the integer or numerical values in the columns to categorical values. So what we do here is that, first of all, we cast the horsepower values as integer, right? And then we create categories, 3 categories. If it's a low, medium, and high for the horsepower, so that we can categorize each value in the horsepower as low, medium, and high. So we take a huge or a very large spectrum of numerical data, and then we categorize them into 3 categories only. And this is how we do it. Actually, there's we create bins using np.linspace, and we take the minimum and the maximum, and then we define how many groups or how many bins we want to categorize our data, and then we just we create here a new column called horsepower dash bin, and we cut the horsepower and then we put it into the bins, okay, using this piece of code here. So it's pandas.cut, and then we give it those parameters. Now let's see what happens when we run this. So as you can see here, it has created a new column called horsepower bin, and it categorizes the horsepower to 3 categories. Now, if we want to see how many cars with low, medium, and high horsepower, now it's easy. So we can see here that we have 153 low, and so on and so forth. Next, we're going to start implementing the Matplotlib to visualize the data that we have. And in order to do that, excuse me, we are using the most powerful visualization library out there, and each data scientist should know how to maneuver or how to work with the Matplotlib. And it's relatively an easy library, and it's straightforward actually. And in this example here, what we're doing is that we're creating bar charts. Okay, so first we mentioned that we want the visualization to happen here within the notebook, not in a pop-up window. So we mention it's inline, and then we import it. For some reason, we already imported it, so there's no need for this one here. And then we import the pie plot, and then from the pie plot we choose the type of the plot. So here it's a bar plot, and then we feed it the values. It's very straightforward actually. So we give it the group names, which are a low, medium, and high, and then we give it the column horsepower bin with value counts. So as you can see here, it's very straightforward. So it gave us the low, the medium, and the high. Don't worry about this one here. that's it. It's straightforward actually. Now, next, so what we're doing here is we're showing the original horsepower values with bins, so that it will show us here that most of the cars that we have fall in the category or the values between 50 and around, I think, 110 horsepowers. So most of the cars between 50 and 110 horsepower, there are more than 140 of those cars. And it's similar here. It's like a more of a generalized overview, and here if we want to dive into the details. And as you can see, it's very easy, very straightforward. It's a histogram type of plot. So straightforward. We mention or we write plt.pyplot.hist, so it will show us the histogram representation, and we mentioned that we want 3 bins in the histogram, so as such it creates 3 bins here. All right. Next is also a very important concept. It's actually the reverse of binning. It's called dummies. As you recall, in binning, we changed the numerical values to categorical values. In the dummies, we're doing the opposite. So we turn the categorical values into numerical values. So what we do here is that we say pandas.get dummies for this column, which we know is a categorical column, and next we rename the values. We give it we're changing it to be gas and diesel, while creating new columns. So again, let's go through this again. The fuel type has 2 values, a gas and a diesel. So rather than having one column and mentioning gas and diesel for each row, we can create 2 more columns, okay? And the first column is going to be fuel type diesel, and the second one is going to be fuel type diesel, fuel type gas. It should be fuel type gas, sorry. Well, to get more clarity, let's take those 2 lines of code, sorry, and just put them here. And let's view the first one. So let's see how it looks like. So it creates 2 columns, as we said. Each column represents a value in the fuel type. Let's say we had three values in the fuel type, diesel, gas, and electric. So it's going to create 3 columns, 3 new columns. And wherever it's gas in the fuel type, it's going to be 1 in the gas column, 0 in the diesel, and 0 in the electric, so on and so forth. All right, so what we're doing here is that then in the next column, we're just simply renaming the column names. Okay, so now we're going to drop the fuel type and replace it with those 2 columns. All right. Right. So we have a column called diesel and a column called gas, and we dropped the fuel type column. Okay, so let's go over the dummies concept again. If we have a column with specific categorical values, we're going to change that into numeric, and again, and also we're going to create new columns. Each column represents a value, a categorical value in that original column. Okay, I hope that's clear. And finally, we're gonna save our cleaned data, the data that we have worked on, we have wrangled, we're going to save it into a CSV file. And that's simply the statement. Okay, guys, I hope that was informative and useful for you. I know maybe the rhythm of this video is much faster than the previous one. Please leave me comments and let me know if this type of format is okay or is good. I welcome all of your suggestions to improve this channel. And that's it for now. Take care and see you in the next video.